Welcome to weeks 2 to 4 in the personal transport unit for the HSC Engineering Studies School of Now course. Okay, let's have a look and see what we've actually got here. Here we go in current topics to navigate through, and you can see I've changed this now so that the link is actually 2 to 4. Right, click on that and we end up at the ignition page. Now here, basically what we're doing at this section is looking at the mechanics within personal and public transport and going back over the topics to make sure that we've got our heads around on how to do these equations. The good thing about this is a lot of this stuff we've already worked on. It's already come out of the braking systems unit. So here we've sort of got a situation where we're going back and reviewing the work that we've done. So have no fear if you've actually got some worries and concerns about doing the mathematics. We're going back and we're reworking them and cementing them into our mind. Okay, so outcomes, learn abouts, learn tos, basically understanding the, I've got to get, there's a spelling mistake there, understanding engine mechanics and hydraulics. And if you can successfully work through the mathematics and graphical methods to solve the problems, then you're on the right track. So over the next couple of weeks, I've only got this one ignition page, but essentially like the first bit is just starting to each week understand the mechanical processes that are occurring. So this week it is going to be static friction and the coefficient of friction. So we're looking at this stuff here. We're going to come back and look at simple machines and also potential energy in there as well. Your evidence of learning is actually doing the questions themselves. And finally, I want you guys to really think about how we want to do assessment task 2. I'm happy to discuss this with you and work it out. Like I said, at the moment, it's an open book exam, but how long should we leave that book open for? Is one day enough, or would you like a week to actually do it? And that's what I'm looking at here. How do you wish to show you at your best? Again, the weekly learning video will appear, which is what I'm actually doing now. So if we go to next, we're just working through this whole thing of friction. Okay, so once this page loads up, there's a lot of work here to actually understand. Okay, so the main thing is, here's a NESA formula sheet. And here is the equations or the formulas that we'll actually be using. Now, when you go through these documents, like I said, I'm pulling apart 6 different textbooks to try and get it right for you in the easiest possible language that I can use. When you go through, like they're actually using different things. So I'll just come down here and show you. So here we've got Fn versus Fg versus... It gets a little bit confusing with all of this. So what I'm suggesting that we do, we stay focused on this. These are the formulas that we use. Let's stay focused on it. So there's another spelling mistake. My goodness. So F stands for the frictional force. N is the normal force. So the weight of the object that's actually coming down. And mu, the Greek symbol mu, is for the coefficient of friction. Okay, so 2 different formulas that we work with. Frictional force equals mu multiplied by normal force, and to find out what the coefficient of friction is, mu, it is tan the angle. Now this angle is a little bit like, like here a lot of the times they'll actually give you what the coefficient of friction is. They'll actually state it. But to find it out, this is a great little video which shows you how it's done. So basically what they're doing, they're lifting up this plank till it gets to 15 degrees and then the book starts sliding. So again, coming back to our formula, mu equals tan angle, tan 15 degrees equals 2.68. So the coefficient of friction between this timber and the book is 2.68. Again, really easy to understand when you know what you're looking for. Okay, so good little video on the coefficient of friction, good one to show you here. Only watch the first minute. You're more than welcome to go on longer, but the first minute shows you how they do this experiment. As for a textbook reference, if you're having a look at Rochford, pages 76 to 77 also covers this content if you want to go and start making notes there. Okay. Explanation of friction, starting to break it down into the formulas. So while we've actually got the weight pushing down this way, we've got the weight coming down this way, the normal force holding it onto the slope is this way. Like I said, you've got lots and lots of different forces in action here that we need to start to calculate. What is friction? Good little video to get your head around it. And then we're starting to talk about how friction works. So in this case, we have an applied force, right? We have an equilibrium where nothing is actually moving. And then we've got motion, which is kinetic. So Fs is static friction. Fk is kinetic. Okay, look, these things drive me bananas, so I can understand that they'd be actually challenging for you. But again, just take your time and work it out. So we're talking about static or kinetic, so it's actually moving or it is still, okay? Coefficient of friction, here we go here. Here's our formula as we're starting to work it. And in there's a couple of examples that you can actually work through to have a look and see what it's doing. Here again, we've got, if we're starting to break down the friction itself, we've got the weight of the box coming down, and then we've got the normal force pushing it up and holding it steady. So as this guy's applying the force to push the box, we've actually got friction adding on the box here itself as well. So they need to get over this level of friction for the box to start moving. Okay, so that's where that comes in. Here when we've got inclined planes, we've got different angles that are starting to change, and that's where we're starting to put in the calculations to bring them all back to the same angle, to the same calculation that we can understand. Again here for the top, we've got mass by gravity equals sine angle, and then down here we've got the normal force by the angle as well. Okay. Again, read through it, make sure you get a good understanding of it. I'll give you some examples of how they actually work through so that you can start to understand it. When we're coming down here, we've got here like an analytical method of doing it. Here's the analytical solution. So starting again, taking your space diagram, making it a free body diagram, and then starting to work through the analytics that way. The second one is the graphical solution. And we'll break this down a little bit more, but as you can see here, we've got the a scale set, right? 10 millimeters equals 25 newtons. Here we've got 100, so it turns into 200. Oh, sorry, that's that answer there. So we've got 100 here, which is 250. We've got a scale here that's happening for mu. So we've got a ratio of 55 over 100. There's your 55 millimeters, and they start to draw it. Look, I'll be honest, this one's going to take a little bit of work. I know I'm not actually describing it because I'm going to have to step you through it in how to construct these, and I will do a video for you. Okay, so for this week as well, as we click onto the next button to move through the course, we've got our Zooms. So our Zoom meetings will appear here for over the time period. Right, so then go next. And here are some equations that you can actually work through. Starting with the simpler one, like a 100 kilogram block is resting. Determine the horizontal force P to just cause the block to slide if the coefficient of friction is 0.5. Okay, so again, starting with one that's quite easy, and as you go through, they're getting a little bit harder as you go and applying the formulas. Right. I'll do the work solutions for these, and they'll appear later this week. So I'll open them up for you so you can have a look at it. And I'll also set, like I said, I'll do a video about drawing this as a graphical solution. Thanks for listening to me, and I'll see you in the Zoom.